Hi everyone, this is Anthony. I'm here with my son Jack. Say hi, Jack.
Hi.
So here we have a Arduino tank platform that Jack and I decided to start experimenting with. Jack and I love RC cars and quads and drones and anything electronic related, and we decided we wanted to learn how to start doing our own robotics platform. So this is our first experiment we currently have here. So here we have our we have a tank platform. We purchased this off of Amazon, and it just came with the chassis, the metal chassis, the tank treads, and the two motors that are on the inside and the gearboxes. What we have purchased is on the inside. As I said, we're RC guys, so we purchased two electronic speed controllers down there. They're zip tied in. So they're two brushed speed controllers. On the front side, and we'll let Jack point these things out, we have our Spectrum receiver, which is there, which is communicating with our Spectrum radio transmitter over there. We have the Arduino Uno, which is hidden in the back there.
Yeah.
We have sitting on top of it a Adafruit motor shield. That's not actually something we really need, but it was one of the things we were experimenting with because you can communicate through I2C to the motor shield, and then we do the pulse width modulation from that, so that we were not using up some of the pins on the Arduino, but we might remove that later on. We also have a battery filtering circuit, which is that green board there. We just have some capacitors and stuff in there because we drive the power from the 2-cell LiPo battery, which is right there, which goes into the speed controllers and then feeds this power board. And then this power board comes in from here, and then we take some of the power to go to the Arduino, and then we take some power to go to the Spectrum receiver. So a few things to maybe show real quick, and then we're going to do a drive, which we'll record, and then we'll splice into this video. So we have our Spectrum radio, and then we have two switches down here.
Under the tank radio.
Yep, underneath the tank we have two switches for the two speed controllers. So when you need to have like a little initialization program that sends a neutral throttle to the speed controllers for so many seconds before the speed controllers will arm. So that's something you have to know about electronic speed controllers from RCs, is that they have that delay in there, so that way you just can't turn the unit on at like 70% throttle. So what we wanted to do and showcase a little bit is that the tank is actually working from the throttle input and the steering. So we're doing the mixing ourselves in the board. So if I were to give it hard throttle, hard right turn, and a little bit of gas, you can see we move the right tread. If we go back, we move that tread. So as you can see here, we have our own mixing going on, and when we do the more driving embedded video right after this, you'll get to see more of how all this works. Hi everyone, so we're back now and we're ready to do our driving review of our tank, and Jack will be our test driver for this today. So Jack, why don't you give a little drive and show him how some of the steering works.
So you have to give it throttle to turn it.
Yep, so as you can see, we use it just like a normal RC. You have your throttle and your steering. We don't have all the mixing perfect in the Arduino. We see some things we would like to optimize, but as a moment you can see when we do full throttle, we are just stopping the one tank tread and then speeding up the other one. When you give it slight gas, or you give it a slight turn as you're driving, we speed up and slow down the two treads to try and keep a constant speed, but a little bit of turning. And one thing we will note, I know it probably looks a little funny with the 3D printed board sticking out of the front of it, but we've had many problems with electrical noise and what we believe is EMF coming from the DC motor. So everything was actually meant to be a nice, clean setup with all the electronics embedded in the tank chassis, but we haven't been able to solve those issues of what we believe is the EMF from the motor. We've tried ferrite beads and all sorts of stuff, but we can't seem to get rid of some of the interference. It only happens at like full throttle, and this is probably mostly related because they're very inexpensive, cheap brushless motors, brushed motors. We would like to replace the units with some brushless motors, which would probably solve, we think, many of our problems we currently have.